This is section 7.4 and 7.5 of Honors Algebra 2, equations in quadratic form and graphing from vertex form. We're going to start with section 7.4, equations in quadratic form. So notice the similarities between these three equations. The first one just looks like an ordinary quadratic equation, x squared minus 5x minus 6 equals 0. And we know that we can solve that. That one is actually factorable. But even if it wasn't, we could use the quadratic formula, or we could complete the square. So this first one is said to be quadratic in x. The second one is 3x minus 2 quantity squared minus 5 times 3x minus 2 minus 6 equals 0. Notice the only thing that's different between that and the first one is we replaced x with 3x minus 2. So this one is said to be quadratic in 3x minus 2. That means with respect to the expression 3x minus 2, it's a quadratic equation, and so we can solve it like a quadratic equation, even though it looks more complicated. It's really the composition of a linear equation and a quadratic equation. The third one is 1 over 2x quantity squared minus 5 times 1 over 2x minus 6 equals 0. And again, all we've done to go from the first one to the third one is replace x with 1 over 2x. So this one is quadratic in 1 over 2x. So we can treat it like a quadratic equation, and we can solve it like it's an ordinary quadratic equation. So let's see how we do that. Any equation is in quadratic form if it can be written as a times some function of x squared plus b times that same function of x plus c equals 0, where f of x is some function of x. It could be a linear function, it could be another quadratic function, it could be a radical function, it could be a rational function. If it's some function of x, and it's otherwise in this form, where it's that function squared plus a number times that function plus another number equals 0, then it's an equation in quadratic form, and we can solve it as a quadratic equation. So here's how we do it. I've taken our second one from above, the 3x minus 2 equation, and the way we do this is to say, let's let y be 3x minus 2. We could use z or w or a, whatever variable you want to use. Take another variable, smiley face, take another variable, and set it equal to the thing that is being squared. In this case, the 3x minus 2. That way I can rewrite my original equation with y instead of 3x minus 2. So it's y squared minus 5y minus 6 equals 0. And I can solve that in terms of y, and then replace y with 3x minus 2 and solve it for x. So let's solve it for y first. This one happens to be factorable because I can find two numbers that multiply together to give me negative 6 and add together to give me negative 5. So how about negative 6 and positive 1? So I'll have y minus 6 and y plus 1. So that means y minus 6 equals 0, or y plus 1 equals 0. So y equals 6, or y equals negative 1. But remember, I'm not solving for y, I'm ultimately solving for x. So I'm going to replace y now with 3x minus 2. So 3x minus 2 equals 6, or 3x minus 2 equals negative 1. So that means 3x equals 8, and x equals 8 thirds, or 3x equals 1, and x equals 1 third. So my solution set is 1 third comma 8 thirds. So I pick another variable, replace the expression that my equation is quadratic in with that variable, solve it for that variable, replace it with the original expression, and solve for the original variable. Not really that complicated. Here's another example. This one doesn't quite look like it's in quadratic form, but it is. 3x plus 4 times the square root of x minus 2 equals 0. So let's let and I'll choose z this time. Let z be the square root of x. That means that z squared is the square root of x squared, which is x. So I can replace that first x with z squared. And I can replace the square root of x with z. And I have an equation that's just a quadratic equation with z. So let z be the square root of x, the expression there, which is really what is being squared to get the x at the front there, because the square root of the square root of the square root of x is x. So z squared is x. Now I can solve this for z, and this one, it turns out not to be factorable, so I can use the quadratic formula, and I'll have z, since I'm solving for z right now, z equals negative b, which is negative 4, plus or minus the square root of b squared minus 4ac, so that's 16 minus 4 times 3 times negative 2, all over 2 times 3, 2a. Okay, so z is negative 4 plus or minus the square root of negative 4 times 3 is negative 12 times negative 2 is positive 24. Positive 24 plus 16 is 40, all over 2 times 3, which is 6. So z is negative 4 plus or minus the square root of 40 is the square root of 4 times the square root of 10. So 2 square root of 10 all over 6. I can cancel the 2 out of everything. So negative 2 plus or minus the square root of 10 over 3. That's what z is. But I want to know what x is. And z was the square root of x. So the square root of x is negative 2 plus the square root of 10 over 3, or the square root of x is negative 2 minus the square root of 10 over 3. And so that means 3 times the square root of x equals negative 2 plus the square root of 10, or 3 times the square root of x equals negative 2 minus the square root of 10. And we have to be careful with that one, because negative 2 minus the square root of 10 is going to be negative, and the square root of x can never be negative. So this actually, on the right, does not lead to any solutions, because the square root of x cannot be a negative number. On the left, negative 2 plus the square root of 10 is going to be a positive number, because the square root of 10 is bigger than 2. So negative 2 plus the square root of 10 will be a positive number. So let's work that out and find out what x is. We can square both sides. So we'll have 9x equals negative 2 plus the square root of 10 quantity squared. Alright, I need to FOIL that out. So 9x equals negative 2 plus the square root of 10 times negative 2 plus the square root of 10. So 9x equals 4 minus 2 times the square root of 10 minus another 2 times the square root of 10 makes minus 4 times the square root of 10, and then plus square root of 10 times the square root of 10, which is 10. So 9x equals 14 minus 4 square root of 10. Divide both sides by the 9, and x equals 14 minus 4 square root of 10 over 9. So that is my one and only solution. Again, I threw out the one on the right because negative 2 minus the square root of 10 is a negative number, and the square root of x can never be a negative number. Number 3, x to the fourth plus 7x squared minus 18 equals 0. If we let w be x squared, again it's the thing in the middle term, then w squared is x squared squared, which is x to the fourth. So the x to the fourth is w squared plus 7 times w minus 18 equals 0. Alright, is this factorable? There are two numbers that multiply together to give us negative 18 and add together to give us 7. About positive 9 and negative 2. So then w equals negative 9, or w equals 2. But we're not interested in w, we're interested in x. So x squared is negative 9, or x squared is 2. So that means x equals plus or minus the square root of negative 9, or x equals plus or minus the square root of 2. Okay? The square root of negative 9 is the square root of 9 times the square root of negative 1. Remember, the square root of negative 1 is I. The square root of 9 is 3. So this is plus or minus 3i. And the square root of 2, we can't simplify any further. So I have 4 solutions here. I've got 3i, negative 3i, positive square root of 2, negative square root of 2. My solution set is the set of all 4 of those. Okay, that's enough with 7.4. 7.5 is on something completely different, graphing a quadratic equation when it's in vertex form. So let's start with a very simple quadratic equation. The equation y equals x squared. We can't get any more simple than that if it's going to be a quadratic equation. Quadratic means the variable, the highest power of the variable is 2. So the highest power of x here is 2, and I'm not adding or subtracting or multiplying or dividing by anything else. So this is the simplest quadratic equation I can graph. So we're going to start with that. And we'll see that all other quadratic equations are simply taking this original one and shifting it and moving it, making it narrower or wider. So let's start with this one. And I'll just do it the way we can graph anything we're unfamiliar with. We'll just pick points. Pick numbers for x, plug them in, find y. So what is y if x is 0? Well, 0 squared is 0, so y is 0. So I've got the point 0, 0 on my graph. What is y when x is 1? Well, 1 squared is 1, so y is 1. Alright, so I've got the point 1, 1. What is y when x is negative 1? Well, negative 1 squared is positive 1. Alright, so negative 1, 1 is on my graph. So there's 2 different numbers for x that give the same number for y. Does that make this a function? Yes, it's still a function. I just can't have it the other way around. I can't have the same number for x going to 2 different numbers for y. So this is a function. What happens when x is 2? Well, 2 squared is 4, so y is 4. 2, 4. What happens when x is negative 2? Negative 2 squared is also 4, positive 4. Okay, what happens when x is 3? 3 squared is 9, so y is 9. And when x is negative 3, we also get 9. And we could keep going. When x is 4, we'll get 16, and so on. And of course, there are numbers in between these. When x is 1/2, we'll get 1/4. When x is 1/3, we'll get 1/9, and so on. If we were to graph all of those, we would see that they connect in a nice smooth curve that looks like that. This shape is called a parabola. The graph of any quadratic equation, graph of any equation which the highest power of the variable is 2, is a parabola. Notice that this parabola and all other parabolas are symmetric. That means one side is a mirror image of the other. The line of symmetry here, which I'll draw in red, goes straight down the middle vertically. That's the line of symmetry. Notice that the left-hand side is a mirror image of the right-hand side, and vice versa. So here the y-axis is the graph's axis of symmetry. That's the line of symmetry. We call it the axis of symmetry. The point where the parabola crosses the axis of symmetry, which is that point at the origin in this case, is called the graph's vertex. It's the vertex of the parabola. All parabolas have one vertex. In this case, that happens to be the origin, 0, 0. That's the point where the parabola crosses the axis of symmetry. So what does the graph of y equals negative x squared look like? Well, since the negative is not in parentheses with the x, the negative is not being squared. you're still just taking x, squaring it, and then making that number negative. So when x was 0, we would still get 0 because negative of 0 is still 0. But when x is 1, we'll have 1 squared, which is 1, and then we'll make it negative, so we'll get negative 1. When x is negative 1, we'll have negative 1 squared, which is positive 1, and then we'll make it negative, so we'll get negative 1. So what this is doing is taking every y value and taking the negative of it. So when x was 2, last time we got 4, now we'll get negative 4. When x was negative 2, we got 4 previously, now we'll get negative 4. When x was 3, we got 9, and now we'll get negative 9. And when x was negative 3, we'll now get negative 9 as well. So this just takes the whole graph and reflects it over the x-axis. It has taken the graph and flipped it over the x-axis. That's what happens when you shove a negative in front. So thus the graph of y equals ax squared, where a is any real number, opens up if a is positive, opens down if a is negative. Because by putting the negative there, it's going to reflect it over the x-axis. The larger the absolute value of that a is, the narrower the parabola is. So if I have y equals 2x squared, like this, I've made my parabola narrower than it was without the 2. But if I have y equals 1/2 x squared, I've actually made my parabola wider than it was without the 1/2. So the larger the absolute value of a, the narrower the parabola. Y equals 4x squared is going to be narrower than y equals 2x squared. Okay, y equals 1/4 x squared is going to be wider than y equals 1/2 x squared, because 1/4 is smaller than 1/2. This is the absolute value, so if I make it negative, all it is doing is flipping the original one over the x-axis. So y equals 2x squared and y equals negative 2x squared are the same width. They're just flipped over the x-axis. To graph y equals a times x minus h quantity squared, so we're taking x, subtracting something off from it, and then squaring it, we're going to shift the graph of y equals ax squared, and we know how that works, horizontally h units. We're going to shift the graph, the original graph, which we know what that looks like, we're going to shift that horizontally by h. If h is positive, so if we're taking x minus 2, we're going to slide to the right by 2. If h is negative, so we're doing x minus negative 3, which is really x plus 3, we're going to slide to the left. So it's sort of counterintuitive. The graph will have the vertex at h, 0, because it's been moved from 0, 0 over by h units. So it's now going to be at h, 0. And its axis of symmetry is the vertical line, x equals h. So here's two examples. Y equals x minus 3 quantity squared. I am subtracting off from x a positive 3. So I'm moving to the right by 3. Again, that's counterintuitive. You see a minus in there, you think you should be moving to the left, but you're actually moving to the right. The new vertex is here at 3, 0, and the axis of symmetry is the vertical line that goes through the vertex. So it's the vertical line x equals 3, or x equals h in the general form of the equation. When you have y equals x plus 3 quantity squared, x plus 3 is really x minus a negative 3. So we are subtracting off from x a negative 3. H is negative 3. So we are shifting to the left by 3, putting us at negative 3, 0 for the vertex, and the axis of symmetry at x equals negative 3. And every other point on the parabola is getting shifted over to the left by 3. So the point 1, 1 is now going to be at the point negative 2, 1. Let's say instead of subtracting a number off from x, we're actually subtracting it off from y. To graph y minus k equals ax squared, which notice is the same as adding the k to the other side and having y equals ax squared plus k, so those are the same. Shift the graph of y equals ax squared vertically, k units. So if we have y minus 3 equals x squared, and notice that's equivalent to y equals x squared plus 3, then k is 3, and we can shift it up 3. So the vertex was at 0, 0. It's now at 0, 3. If we have y plus 3 equals x squared, which is really y equals x squared minus 3, then k is negative 3, because it's y minus a negative 3, and we slide down 3. We shift down 3, and we end up at 0, negative 3 for the vertex. And every other point on the parabola also shifts down 3. The point 1, 1 now becomes the point 1, negative 2. Let's put it all together. A quadratic equation is in vertex form when y minus k equals a times x minus h quantity squared, or we can add the k to the other side and have y equals a times x minus h quantity squared plus k. Anything like that is in vertex form because we can pick out the vertex. The vertex is always h comma k. We have to be careful with the sign now. And the axis of symmetry is the line x equals h, the vertical line that goes through the vertex. So let's see some examples. Let's graph y minus 2 equals x minus 4 quantity squared. So the vertex is h comma k, which here is 4 comma 2. H is the number we're subtracting off from x, which is 4. K is the number we're subtracting off from y, which is 2. So the vertex is going to be at 4, 2. And I will label the vertex. The axis of symmetry, which I'll draw in red, so it's not actually part of my graph, but it's there to help me draw the graph, goes vertically through the vertex. That is the line x equals 4. It's a vertical line, and we know how to write the equation of a vertical line. This parabola, I know, is going to open up. How do I know it's going to open up? Because there's no negative in front of the parentheses here. Since there's no negative there, it's going to open up. Right? If there were a negative, it would open down. So I know it's symmetric, so I can use that to my advantage in drawing the graph. So any point I make to the right of the axis of symmetry, there's an analogous symmetric point to the left of it. So for example, if I make a little chart, if x equals 5, which is 1 to the right of my vertex, I'll have 5 minus 4, which is 1. 1 squared is 1. So y minus 2 would equal 1. So y would equal 3. So the point 5, 3 is on my parabola. But since my parabola is symmetric, that means the point 1 to the left of the vertex, which would be when x is 3, will have the same y value at 3. That way I'll have that point symmetric to the point I just made at 5, 3. I'll have this point 3, 3. Notice I plotted and labeled 3 points on my parabola. You need to label with ordered pairs 3 points on your parabola, and one of them needs to be the vertex. Okay, I can make another point. What happens when x is 6? So 2 to the right of the vertex. 6 minus 4, and that's 2, and 2 squared is 4. So y minus 2 would be 4. That means y equals 6. So I have the point 6, 6. That means if I go 2 to the left of the vertex, say at 2, I will also be at 6. And now I can draw the rest of my parabola. And you need to put arrows on both ends because it goes on forever. Alright? Y minus 5 equals negative x plus 2 quantity squared. So when I know it's going to open down because there's a negative in front of the parentheses. And now let's find the vertex. The vertex is h comma k. H here is the number we're subtracting off from x. So if it's x plus 2, it's really x minus a negative 2. So h is negative 2. K is the number we're subtracting off from y. So that's 5. Y minus 5 means K is 5. So the vertex is at negative 2, 5. I know it's going to open down. And I know the axis of symmetry is going to go vertically through the vertex. So what line is that? It's the line x equals negative 2. X equals the x-coordinate of the vertex. Okay? Let's make a little table. Let's go 1 to the right of the vertex. When x is negative 1, what is y? We'll have negative 1 plus 2, which is positive 1, squared is 1, but that's made negative. So we'd have y minus 5 equals negative 1, which means y equals 4. So when x is negative 1, y is 4. When x is 1 to the left of the vertex at negative 3, we're also going to be at 4 because of symmetry. So we're at negative 1, 4, and negative 3, 4. And let's plot another point. If x is 0, 0 plus 2 is 2. 2 squared is 4. So we'll have y minus 5 equals negative 4. That means y equals 1. 0, 1. 2 to the left of the vertex, when x is negative 4, will also be at 1. Now I have enough to sketch my parabola. A nice smooth curve with arrows on both ends. So notice that's just taken the original graph we made, y equals x squared. It's reflected it down. It's shifted it to the left and up. It's called a transformation of the original graph. One more. Y plus 6 equals 2 times x plus 1 quantity squared. So the vertex is hk. H is the number we're subtracting off from x. So it's really x minus negative 1, and h is negative 1. K is the number we're subtracting off from y, so it's really y minus negative 6, so k is negative 6. My vertex is at negative 1, negative 6. Does this open up or down? It opens up because there's no negative in front of the parentheses. If that was a negative 2, it would open down. But it's a positive 2, so it opens up. My axis of symmetry goes vertically through the vertex. So it's the line x equals negative 1. And let's plot a couple of points. Label the vertex here, negative 1, negative 6. And let's plot a couple of points using symmetry. If x is 0, so 1 to the right of the vertex, 0 plus 1 is 1, 1 squared is 1. 1 times 2 is 2, so I'll have y plus 6 equals 2. Means y equals negative 4. When x is 0, y is negative 4. When x is 1 to the left of the vertex at negative 2, y will also be at negative 4. Notice this is narrower than my original parabola because I multiplied the x part by 2. The bigger that number, the more narrow it is. When x is 1, so 2 to the right of the vertex, we'll have 1 plus 1, which is 2. 2 squared is 4. 4 times 2 is 8. So we'll have y plus 6 equals 8, which means y equals 2. So at 1, I'm at 2. And 2 to the left of the vertex at negative 3, I will also be at 2. Okay, let's label some points. We've got the point 0, negative 4, and its symmetric point at negative 2, negative 4. Let's draw the curve. And this is narrower than the original parabola. Now here are your immediate practice problems. 2 of them. First one, an equation in quadratic form. You're going to solve it for x. Number 2, you're going to graph that parabola. It works like the last one we did. That is the end of section 7.4 and 7.5.